In this video, I will derive Laplace equation. The Gauss law for electric field is written as del dot D vector is equal to rho V. D vector is electric displacement vector and rho V is free charge density. D vector is defined as epsilon times electric field vector, and we can put the value of electric displacement vector in equation 1. We will get del dot epsilon E vector is equal to rho V. Now suppose we have a scalar field. Scalar field I am denoting with A, and a vector field that I am denoting with B vector, and I want to take the divergence of their multiplication. Then this can be written as gradient of the scalar field del A dot the vector field B vector plus the scalar field A multiplied by the divergence of the vector field B vector. And if A is constant everywhere in the space, then gradient of A will be 0. If A is constant. Suppose we have this scalar field A and its value is same on this line, its value is same on this line. So the direction of gradient of A will be perpendicular to these equifield lines. And if A is same everywhere in the space, then gradient of A will be 0. And we are left with only one term, that is this term, A multiplied by divergence of the vector field. So if the scalar quantity is constant everywhere in the space, then its gradient is 0, and we get only one term here, A times del dot B vector. The same is the case here. We have del dot epsilon E vector, and for Laplace equation we will take homogeneous medium in which epsilon is same everywhere in the space. So epsilon is constant everywhere and the gradient of epsilon is 0, and we get only one term, and that term is epsilon times del dot E vector divergence of electric field vector is equal to rho V, or we can write it as del dot E vector is equal to rho V upon epsilon. Now electric field is defined as negative of the gradient of scalar potential V. So we can put the value of electric field here, and we will get del dot del V is equal to minus rho V upon epsilon. Del dot del operator is also written as del square. So del square V is equal to minus rho V upon epsilon. This equation is known as Poisson's equation, and if we take free charge, charge free region, if we take charge free region, in that case the volume charge density is 0 and we are left with del square V is equal to 0. Del square is Laplacian operator. Laplacian of V, the scalar potential is 0 in a charge free region, and this is our Laplace equation. Del square V is equal to minus rho V upon epsilon. This is known as Poisson's equation, and del square V is 0 for a charge free region. In a charge free region, this is known as Laplace equation.